Good morning, good afternoon, ladies and gentlemen. Welcome to another series of online lessons. If you haven't already, please subscribe to this channel and leave a like for this lesson. Now, in today's lesson, we are going to look at indices and logarithms. And basically, on indices, we'll look at the laws of indices and more focused on the application of the laws. So I'll just state the laws, then we'll go into the application of the laws. All right. And the laws that we're going to look at, first of all, is when something is raised to some power. All right. So maybe if you have a raised to the power n raised to the power m. So basically, here these powers can be written as a to the power n times m. Okay. The confusion that you should look out for is where maybe you have a raised to the power n and m is raised to the power k, for instance. Okay, now in this case, this would be a raised to the power n times m raised to the power k. Okay, so this is a confusion that you should look out for. So this is the first law. The laws are not in a specific order. Yeah, so for the second law is when you have same bases, that is a raised to the power n times the same number raised to the power m. So if the bases are the same, you can simply add powers. Okay, so that is a, you just get one of the bases a, then you say n plus m. So here, basically, if you see the powers are adding, it basically means the bases were the same and they were multiplying. Okay. Another thing is where you have the powers dividing. So that is a raised to the power, the bases dividing. So a raised to the power m, n is being divided to a raised to the power m. Since the bases are the same, and in this case they are being divided, meaning that the powers will subtract. You start with the numerator power, that is a raised to the power n minus m. So if you see powers subtracting, meaning that their bases were being divided, or if you see bases being divided, meaning that the powers can be subtracted. Okay, so that is number 4. The other one that we can talk about is maybe this one, number 3. Is it number 4? Yeah. Number 4, maybe you have, okay, any number raised to the power 0 is equal to 1, as long as that number is not 0. Okay, let me explain this. So basically, a number, I don't know where I'll write it from. Let me just move here. So a number raised to the power 0 can be written as that number raised to the power some numbers of the same magnitude that are numbers of the same magnitude that are subtracting. Okay, so n minus n, any of these numbers when they're subtracting and they're of the same magnitude, it will be 0. And basically, from this law that we have here, this can be written as a raised to the power n. Since the powers are subtracting, then you divide by a raised to the power n. And since these are the same numbers, this and this will cancel, which will just give us 1. Now, in a case where a is equal to 0, 0 to the power n divided by 0 to the power n, which is just 0 over 0. And we know that 0 over 0 is undefined because any number divided by 0 goes unbounded. Okay, so 0 over 0 is not 0, is undefined. Okay, so that is why this number should not be equal to 0. Okay, so that is the 4th law. All right, now for the 5th law, we will talk about a number raised to the power some number over number n. Okay, so if you see this can basically be written as the nth root of that number raised to the power b. Okay, so b, the number b here comes to a and over n. So basically, this is the same thing as a raised to the power b, then raised to the power 1 over n. Okay, where when you multiply b times this, you get b over n. which is this law here. Okay, so 1 over n is basically the nth root. Okay, so 1 over n, you know this, 8 raised to the power 1 over n is basically the nth root of a. Okay, so meaning that if you have a raised to the power b, this will be the nth root of a raised to the power b. Okay, so if you have a raised to the power 1 over 2, this will be the square root. So square root, we don't put a 2 there, but square root of a. If it's a raised to the power 1 over 3, this is the third root, which is the cube root of a, okay, and so on and so forth. So this is another law that you should know. Then the inverse law. Okay, so we come to the inverse law. That is number 6. That is when you have a raised to the power -1. This is basically 1 over a. Okay, and this can be coupled with this law here. If you have a raised to the power -c, remember that this can be written as a raised to the power -1 times c, which can be interchanged as a raised to the power c times -1. According to this law here, this can be written as a to the power c, then to the power -1. So basically, this whole thing is acting as a here, which inverse is just 1 over that thing that is in the brackets here. Okay, so basically, a raised to the -c will be equal to a to the power c, or which is just 1 over a to the power c. Okay, that is, let me just write it properly here. That is 1 over a to the power c. Okay, so these are some laws that you should know and you should remember, and maybe just an addition. So this is number 6. We can put number 7 here. Number 7, we can say 1 raised to the power any number. This is going to be 1. Okay, that is a simple thing to understand, because 1 raised to the power any number is 1 times 1 times 1 times 1 any n times, and multiplying 1 any times will simply be 1. Okay, then the other law maybe I can conclude with is maybe I'll say law 6, law 8. If you have any number raised to the power 1, just that same number, because we are multiplying that number 1 time by itself. So basically it doesn't make sense. So just that number. Okay, so these are some of the laws that we're going to apply. Now we can go to the questions. So hope you've copied that. And maybe some more laws will come in as I will be working out the problems. But so far, these are the questions. So let me just zoom out. Where are we? All right, we're here. Okay, so we're on indices here. So I'll leave you to simplify this one. Let me just go to this one, then I'll solve for x on this one. So this one will be work. So let me just so this will be your work, and I'll work out this one. Then you come. I'll also do this one, then put more examples for you. So now for this one, we are asked to simplify. So here, basically remember what we said. So we said 1 over something is just the inverse of that. So basically, this can be written as 4 to the power x plus 2 on this side is equal to. Then here, what we can do is can say this is equal to what? You can say this is equals to root of 16 to the power x minus 1, then raised to the power negative 1, because it's an inverse here. And we can break down this inside here. So remember, when you have a raised to the power, let's say b over c, so we take c as the root. So this is a square root, so c there will be 2. So let me say this is c root of a raised to the power b. So this can be written as 4x, 4x to the power 4 to the power x plus 2 equal to, so this can be written as 16 raised to the power 16 raised to the power x minus 1 over 2. Okay, so the c there is the root, so 2 is the square root, so square root is simply 2, but we don't put a 2 here. Then x minus 1 becomes our b, and this is raised to the power negative 1. Okay, let me just move here. Then this is a 4 to the power x plus 2. We can make these bases the same. So if we want to make the bases the same, we can simply say 16 is equal to 4 to the power 2. That is 4 times 4 will give us 16. So this is 4 to the power 2. Then I'll write this. Then to the power x minus 1 over 2 times this negative 1 that is outside here. Okay, so this can be multiplied to this. So multiplication, remember, if you have a times b, let's say if you have a, this, if you have a like this, then b times c, this can simply be written as a and multiplied to this. So this is a times b, then times c. Okay, so that is multiplication. So now in this case, we're going to have 4 raised to the power x plus 2 equal to 4 raised to the power 2 times x minus 1 over 2, okay, times negative 1 here. So this and that can cancel out. So let me just highlight that this and that can cancel out. And what will remain with is 4x plus 2 equal to 4x minus 1 times negative 1. So I can put the negative 1 here. So times 1, the negative here. Now here we are not solving for the value of x. We're trying to simplify. So what we'll do is we can multiply. We can try to get rid of this part of the equation. So what we can do is we can multiply by the opposite of this. That is 4 to the positive of x 2, so we multiply with a different base, and here we do the same. So since we are not trying to change the meaning of the question, so 4 to the power positive x minus 1. Okay, so basically here the idea is that if these have different signs and the powers are going to add, so on this side we're going to have 4 raised to the power, this is a negative x plus minus, sorry, negative x minus 1 plus x minus 1, which will give us 0. And this side, this is 4, that is x minus 1 plus x plus 2. Okay, so we can further simplify these. So this will be, so we can group the like terms. So this x plus this x will give us 2x, and this and this will give us positive 1. So this can be written as 4 to the power 2x, 2x plus 1 equal to, this side we have this and this will simply be 0. So this will be 4 to the power 0. and any number to the power 0 is basically equal to 1. Then here, this will just be, we can leave it like that, or we can simply write it as 4 to the power 2x. Since the powers are multiplying here, we can say times 4 to the power 1, so that we show that bases were dividing. So which can, maybe we can further simplify, but we can, let's further simplify. So this is 2x plus 1, so the bases were multiplying here. So this can be written as 4x. We can divide by 4 by 4. So this and this can cancel out. Will be, so this is, sorry. Okay, so that is 4 raised to the power 2x. Then this will divide over 4 over 4. So this and this goes. Then we're going to remain with 1 over 4 here, which is okay. Then maybe we can even further simplify this. So we can write, we can simplify this to the lowest power, which is maybe 2. So we can say 2, 2 raised to the power 2 will give us 4, and to the power 2x be equal to this, can be written as 4 raised to the power negative 1. Okay, then we can say 2 raised to the power, we can multiply this, so this is 4x, and this side we can say 2 raised to the power 2 to the power negative 1, so this is a 2 raised to the power 4x equal to 2 raised to the negative 2. Okay, so we can say we have completely simplified. So yeah, so basically that is how you are supposed to simplify this. Then if you were asked to find the value of x, since the bases here are the same, you can just equate the powers. So you say 4x is equal to negative 2, but you were not asked to find the value of x, you're just asked to simplify. So this is the simplified part. So now you could say over 4 over 4. So this is x will be equal to negative 1 over 2. Okay, that is if you were asked to find the values of the value of x, sorry. Right, so yeah, so that is how you were supposed to work out question B. So simplify, you're just supposed to end here where you simplify this. And now we can go to question, hopefully you've copied that. So now we can go to question 4. So question 4, you're asked to solve for x. So now in this case, this is where you're asked to solve for x. Let me just move up. So now in this case, you consider the fact that you have some variables with the power x. Even here you have a variable with the power x. Your goal is to make the bases of the variables with the power x have the same bases, or to be the same. So your goal will be to make the variables with the power x to be the same bases. Okay, so here we want this to be to the power, the base 3, so that it matches with this. So this can be written as 3 to the power 2, so that is 3 times 3, which will give you 9. Then there is a power x out here, so we can put this into the power x there. And here we say minus 4. Then this can be rewritten as, since the powers are adding here, so this can be written as 3 to the power x times 3 to the power 1 plus 27 equal to 0. Okay, so that is what we can do there. Then here we can simplify further. So we want the 3 to the power x to be visible here, so we can swap the powers. So this can go outside and this come inside, so that we have 3 to the power x, then to the power 2 minus, so this can be written as 4 times 3, and we have 3 to the power x there. So we want the 3 to the power x to be visible, plus 27 equal to 0. So now here we simplify further. This is a 3 to the power x to the power 2 minus 12 and 3 to the power x plus 27 equal to 0. Now, when you get to this point, it is very easy. You have 3 to the power x there, 3 to the power x there. So you now let 3 to the power x be equal to any letter of your choice. So let's see. Let me use which letter? Let me use maybe J, okay, or P. Okay, let me use P. Okay, so but it can be any letter of your choice. So P, so we can put P where there is 3 to the power x. So this will be P squared. So we let 3 to the power x equals to P. So P squared. So here this will be P. Then there will be a power 2 here. So this will be P squared minus 12. Then this is P. So it will be P plus 27 is equal to 0. Now here what you do is you want to solve for P so that you come and use it here, and you use that to find the value of x. So here this is a quadratic equation, so you can use any of those methods that you know. So here the coefficient is 1, here it is 12, here C is 27. So let me just put here this is A. Okay, so we can say we're looking for P now, so we can say P is equal to negative B plus or minus root of B squared for AC all over 2A. So now we can say this is equals to negative B. So B is 12, so it will be positive 12 plus or minus root of 12 squared. So we can say negative 12 squared, put negative 12 then squared, minus 4 times A is 1, and times C, which is positive 27. Okay, then all over. So the numerator is all over 2 times A, which is 1. Okay, so now that is our P. So we can simplify. So this is equal to 12 plus or minus root of this will be 12, negative 12 squared. So this is negative 12 times negative 12. So this number will never be negative. So be careful how you punch that on your calculator. Make sure you put it in brackets and you square it. Don't just write it as 12 then squared. So put it in brackets, then you square it, which will give you positive 144. Then here we're going to have 108, then all over 2. Okay, so that here, so now we simplify further. So this 12 plus or minus root of, so we subtract here. So this is minus 144 give us 36. So all over 2. Then here we can, root of 36 is 6. So this can be written as 4 plus or minus 6 all over 2. So which is P equal to 12 plus 6 over 2. And also P equal to 12 minus 6 over 2. So here we're going to have P is equal to 12 plus 6. That will give us 18. So 18 divided by 2, that is 10. Oh, sorry, that is 9. Sorry. Then or P is equal to 12 minus 6. That will be 6 over 2. That will be 3. So now here, you might get a positive root and a negative root. So basically, since this is more calculus, so you don't do complex numbers. So usually you should get the positive value. Okay, so get the positive value. But in a case where you have positives like this, we need to get both of them. So if you have a positive and a negative, so if we add a negative, you'd get the positive because the negative part gives complex solution, which we don't want to deal with because this is part of complex numbers. Though you might work it out, but just get the positive value, then yeah. So in this case, we have two numbers there, which is 3 and 6. So let me just check here. All right, so after finding those two values, so since they're both positive, we're going to utilize both of them. So, but if one was positive and one was negative, we get the positive because negative gives a complex solution, which is of no use to us in this real analysis. So we have two values, p is equal to 9 and p is equal to 3. So now we come back here. So we say for p is equal to 9. So we'll replace here. So that is 3 to the power x equal to 9. So now we need to find the value of x. So for this case, to get this x down, we introduce logs both sides of the equation. So that is log of 3 to the power x is equal to log of 9. Okay, so basically, though we've not touched more about logs, we can drop the power here. So according to the log rules, which we're going to look at, so we can drop the power here. So this will become log will become x log 3 equal to log 9. Okay, 9. So now we can just punch this directly on our calculator, or we can make x subject of a formula in advance. So let's make x subject of a formula in advance. X will be equals to log 9 divided by 3, so which you can directly punch on your calculator, which will give you 1.9 and repeating. So this will be repeating. So that is the first value of x. So now we also get the other value of x. So this was for p equal to 9. So now for p equal to 3, for p equal to 3, we have 3x is equal to p. So now where there is p, we can put 3. So this is 3 to the power x is equal to 3. So now what we have to do here is, since the bases are the same, or we could have done the same thing here. So since the bases are the same, there was no need for us to go this route. So here we could have done the same thing. We can make the bases the same. Then we say this would have been equal to 3 to the power x, and we can write this as 3 to the power 2. So basically, x would have been equal to 2. Okay, since the bases are the same, x would have been equal to 2. But you also know the log approach. So the log approach gives a more accurate answer. So this one gives the approximate. So here, basically, we're going to have x equal to 2. Okay. Then same here, since the bases are the same, we can just put the powers. So x will be equal to 1. So we have two answers for x. X is equal to 2 or x equal to 1. So this is how you are supposed to approach this. So you can try the same for the log approach. You would have said 3 raised to the power x is equal to 3. Then you introduce logs both sides. So that is log of 3 raised to the power x equals to log of 3. So you introduce logs like that. According to log property, we can drop this power here. It becomes x 3 equal to log 3. Okay, we divide by 3 here, log 3. So these basically, when you punch them, it will just give you 1, and here we can see just 1 as solved right here. Okay, now let me just put up a few questions for you to work out. Then we now move deep into logarithm. All right, so on simplifying indices, you will work out these problems here. So number 1 is there, which was the first question from the tutorial. Then number 2 will be this one. Number 3 here. Number 4, x to the power negative 13, y squared, x5, y to the negative 7, 12k, negative 6, 5m, negative 5, and that. Then for the equations, then for solving for x, you will work out these problems. 2 raised to the power x squared plus 7x plus 17 equals to 32. 3x, everything raised to the power 2 times 3 to the power 3 equals to 81. 4 to the power x plus 16x 3 plus 14 equals to 0. So I'll be waiting for the submission of this work. Have a good evening.